Okay. Welcome to class 5. You guys made it. Well, still one class to go. So today we will be talking about scientific reproducibility and provenance with a package called rmarkdown. So today the overall goal is to try to teach you how to intersperse text and code into reports that have various output formats. So envision now that you have an rmarkdown document that you guys have been working with all week, and you perform some analyses, you write up some interpretation of it, and then you can click one button and it knits all of this together into your desired output. This could be a PDF, this could be a Word document, this could be a PowerPoint slide, HTML. There are several different outputs. So the overall goal today then is to teach you rmarkdown, and you've done a couple of, you've spent some time with them, but now we're going to get into the details and look a little bit deeper at what you guys have been looking at. So a sort of slight review for us, because we've looked at this before. rmarkdown has 3 different types of content. So the first is this header. We haven't paid much attention to this, but this is called a YAML header, and this is surrounded by 3 dashes, dash, dash, dash. So you can see at the top there, we have 2 bits of information in this header, the title and the output type. We also have text. This is written in a language called Markdown. So you guys have learned a couple of languages this week. One language is R. Another language that we'll be talking about today is called Markdown. And so this is a type of formatting that you can apply to plain text to make it bold, italicized, larger, smaller, etc. And then the third is a code chunk. And you guys have seen these before. You guys have hit that little play button a few times. And this is a code that is surrounded by these backslashes, or this dash, dash, dash. Here we see that you can also comment. So here's some code written in R. You can see that comment that won't be run. And then you have some R code there. So these are the 3 different types of content. We'll be diving into these a little bit more deeply and looking at what we can include in each of these sections. But really this is the overview, and this is how it works. So this rmarkdown document that you've taken, or that you've worked with, has a package that's called knitr. And knitr will then convert this rmarkdown into a typical Markdown document. Right, and again, Markdown is a language, and so this is a text file that has some special characters around some of these texts that then programs know how to recognize. And then what happens is there's a series of transformations that can happen from this Markdown document into, like I said, PDF, PowerPoint, Microsoft Words, slides. So if you notice that Akshay, his slides of the content he presented were written in our Markdown and then converted into slides using the IO slides package there. So knitr runs this document as a fresh R session. This is incredibly important to remember. It's also a good check, because it means that you need to load all of your libraries in the document that document uses. So what that means is that if you have a session open and you have one rmarkdown document and you're doing some work in it, and you have another rmarkdown document that you start doing some work in, and let's say that you load a library in that second rmarkdown document, and let's say it's ggplot because you made a plot. And then you go back to the first rmarkdown document and you go ahead and you try to make a ggplot, it will absolutely work, because you have already loaded, like a library, we load it one time per session. However, if you try to knit that second document, it will work because you loaded ggplot, you wrote library ggplot in that document. But if you try that in the first document, it won't work. So you need to explicitly say each time in each document what libraries you need to run all of the code in that document. So it's nice because it makes sure that we're not sloppy, it makes sure that our code is reproducible, but then also you might wonder, well, why did it work one time and not another time? And so the thing to keep in mind is that we can clear our global environment and run something fresh. That's essentially what knitr is doing. It forgets everything that's there and runs it through fresh to see if it can run through all of the rmarkdown document that you have. So it turns out, though, when it runs through that, objects that you make in one code chunk will be available to code later in those later chunks. So this works exactly like it would be as if when Ali was describing some of her lectures, especially in the Stringer lecture, she said yesterday, make sure to run this chunk to create an object first, and that was at the top of the rmarkdown document, because the object created in that earlier code chunk was then used later on, and this was mitoproteins or something like this. And so it's the same here. So if you generate something at one step, an object at one step in your rmarkdown document, it will be available later. So the way to think about this knitting is it starts with a blank slate and then goes through line by line by line by line and basically knits all of this together, and it will run into an error. And this happens to me sometimes where I'll make an object a little bit lower and then I'll think back and change it, so then I refer to that object before I actually make it. And it works totally fine in my environment, my development environment, because it's an object, it's already there. But when knitr tries to come through, or if I try to start fresh, it would throw an error saying, I can't do something with an object that I haven't made yet. Is that clear? All right. Now, resources. One of the things that we want to do in this mini boot camp is supply you guys with resources to continue your own learning journey. So everything that we're talking about today in rmarkdown is just scratching the surface of what rmarkdown documents can actually do. Here's a great resource. The website is there. Just like a lot of the resources in R, they are free, they're online. There are books that you can buy if you like the physical copy and to write in it, but this is going to be a good resource. Okay, so let's talk about the language of Markdown a little bit. So I said there were 3 different types of text that are included in these rmarkdown documents. Well, the middle one was the actual text written in Markdown. And you can see right there on line number 6, text written in Markdown, you can see that Markdown has 2 asterisks around it. And that's one type of formatting that we can do to this. All right, so what does some of this formatting look like? Well, on the left-hand side is what the code that you write and what that would look like. And the right-hand side, this is the conversion of your text into Markdown. So this is nomenclature that's used and borrowed from HTML, which describes different sizes and different styles of headers. So header 1 is the biggest, and header 6 in this case is the smallest. And so we can see that if we put a single pound sign or a hashtag there in front of a word, that's going to be indicated as a header. If we put 2 hashtags there, we can see that it get smaller progressively all the way up to 6. So a single hashtag or a single pound sign there is going to indicate a header.
Matt, could you expand on, up until now we've been thinking about hashtags as lines of code that are not run, lines in the document.
Yeah.
So how is that? It's also a header, or is it those are the ones the same?
That's a good question. So the question is about these pound signs, and we previously used those to comment out code. Now we still will use this to comment out code, but recall I said that there's just 3 different areas of text within the rmarkdown document. There's the header, there's the text, and there's the code chunk. So the code chunk in the programming language R uses that pound sign to comment out code that says this is code that is not run. So if you have a pound sign in your code, this is considering that this is the R language. What we're talking about now is above that code chunk, the normal text, this is the rmarkdown language. Okay? In the white space. Exactly. Yeah, and so James said it exactly correctly, that this is it's a different language. This is our Markdown language versus the R language. All right, so continuing along R Markdown, we can also change plain text in a few different ways. If we want to just write text, it's text. If we want to put something in italics, we can put an underscore in front of it and behind it. And so this is going to italicize the word. We can also use a single asterisk. If we want to bold something, we use 2 asterisks. And again, we have to put it before and after the word that we want to change to, in this case, highlight. And this will be important because we could highlight an entire sentence. So if you start, say, 2 asterisks before a sentence, our Markdown will look for the next instance of those two asterisks. If you never put it, it will either throw an error or it will bold everything that it sees. So we need to make sure to, if we're going to start some code, we need to finish that code as well. If we want to actually write code and have it formatted in this mono-spaced font, we put a back tick before and after the thing that we want to have look like code. All right. So an important note that I have there, we add 2 spaces at the end of a line to start a new line. So if we just hit an enter after, so we write some text, we put a period, we hit enter, we write some more text, another period, enter. You might be surprised, like I was, to find out that that hard return isn't recognized by our Markdown. If we want to start a new line break, what we need to do is we add 2 spaces. Okay, so we can also have lists. So we can use asterisks to make unordered lists, and we use numbers to make numbered lists or ordered lists. So again, so we've got like some plain text there, and then we've got space, and then we've got bullet 1, bullet 2, numbered lists exactly the same. We have a space in between, and then it's our number. And this will automatically format it into what we call ordered and unordered lists, these bullets and these numbered lists. We can also make hyperlinks. So oftentimes what I'll do is I'll say, okay, if I got some data from uniprot.org, what I'll do is I'll preserve the URL of that I went to, that I downloaded the data. And what I can do is, instead of having this, you saw these Uniprot file names and URLs were quite long. So what I can do is I can turn it and say, this is where I got my raw data. And then if I wanted raw data to be a hyperlink, I would put my the word raw data, just like the word link, in these square brackets. And then immediately after, with no spaces, this, because of a line spacing issue, fell down 1 line. But it's immediately after, no spaces, you in regular parentheses, you can put the URL that you want to generate the link on. We can also insert images. And so we can't quite drag and drop. Again, this is a language, so we need to write the code that's going to identify the language, or to identify the place where we're going to see our image. So what we do here is we have an exclamation mark and then a square bracket, and then we have a link to our image. So in this case, we have a PNG, our images folder, and we have the RStudio logo. So we can insert some of our external images. The other thing that I just figured out, we can also include images, but we can include a URL. And so in a report that I just made, there's a URL from a website called Unsplash, which is a bunch of high-quality open-source images. And so instead of downloading an image and then changing its size and everything and putting it in my document, I was able to just put the URL, and Unsplash allows me to change the pixel width of the image that it's getting from the Unsplash server. So it's quite nice that I was able to downsize the image and put the URL all in a single line of code by just sticking it in between my round brackets there, my round parentheses. We also have equations, so we can format equations. These are surrounded by the money signs there, where if this is your thing, you can get crazy figuring out your sort of equations within your R Markdown. We can also then put our equations in equation blocks. Of course, I just threw a lot at you, but just like all of the other resources from RStudio, we have an R Markdown cheat sheet. So what we can do is, if you look again at the both in the RStudio Cloud, or if you go under the Help menu of RStudio, or if you go to Google for R Markdown cheat sheet, you can find a not comprehensive but quite broad list of the R Markdown formatting that you can use to apply different changes. But if you think about it, we don't need blue text in a crazy font when we're writing some of our scientific reproducible reports. Like sometimes we want to call attention to something, sometimes we want to make a list, and some of the more basic things are easily achievable in this. Okay, so just like I said, you can go ahead and look at the Help menu, R Markdown Quick Reference, and you can pull up both in the Help menu there, both in the viewer, the Help viewer, but then also there's an entire PDF to look at that. All right, so moving on from R Markdown, let's look at the code a little bit. So these are code chunks. you guys have seen these code chunks. You've written code in these code chunks. And some of you have noticed that there is some formatting sometimes around these code chunks. So we're going to talk about the formatting in just a moment. What you can see, though, is that, so we have a code chunk. You can manually write backtick, 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 curly bracket, R, curly bracket, some code, backtick, backtick. So you can manually put this in, and it will automatically be converted into a code chunk. Hopefully, you guys have figured out the shortcuts. We've been imploring you to train your fingers and your brain to try to get used to these commands. Actually, the first time that I was teaching this course, I had to pause in the moment to try to remember. I was explaining the shortcut, but I didn't remember the shortcut, but I could do it with my fingers, so then I had to look down. So hopefully you can get to the point where your fingers just sort of know the shortcut of what to do. But this generates a code chunk, but the code chunk has options. All right, so
insert one quick thing I've seen a lot so far. That code chunk finishes with 3 backticks. If you put 3 backticks in the regular Markdown file under it, like if they get inserted somewhere, the next code chunk will not have a play button. So you just need to delete those out of your Markdown area.
yeah.
I've seen that on several computers now.
Yeah. So Ali was just saying the 3 backticks. If you have floating backticks somewhere in your R Markdown, it will throw off the ability of our studio to identify in this R Markdown document where the code chunk begins and ends. It's similar to what I was just saying about this bold. If you have 2 asterisks at the beginning of a word and you never close that, then you'll have a hard time writing any plain text after it. So that's a really good point. I'm glad actually you solved that problem because I never figured out what Paul's problem was. Okay, so we have now some chunk options. And you've noticed some of this, and I said, well, just ignore that for now. Some of you have asked in the previous classes, well, what does echo mean, and what does evaluate, and what do some of these other words mean? Should we care about those? Well, today is the day to care about those. So we just have some simple code here, and iris is a data set. So this is a data frame. And does anybody recall what the dim function is going to do? This is a base R function. Shows dimensions, exactly. And so this case, we have an iris data set that's 150 long by 5 wide. Okay, so here's the dimensions. And if we just run this code chunk, this is exactly what we would get. Now, we have some different options. So here's the first one. So echo. So if we set echo to be false, echo's default is true. If we set echo to be false, then we change the output. So I'm going to go back. So look at this output. Here's some code, and then here's the output. And if we now look, if we set echo to be false, here's some code. How does that output differ from here to here?
It doesn't show what it is.
Yeah, it doesn't show what do you mean by what it is? You're right.
It says dim iris, so you can't tell what is that.
Exactly. No, you're exactly right. So what ends up happening, so echo equals false, and I guess it's written right there. It hides the code, so you can't see the code that was run. And another way to think about it is it just shows the output. So interestingly, this can be really useful for plots. So if you have some report that you're generating, and let's say you have a code chunk that just needs to generate a plot. Well, for the most part, some of your plots will start getting quite complicated where you have your geom and then you have like another geom because you want some other lines in there, maybe like the geom jitter that Ali was talking about, and then you have some labels and some themes, and your code chunk for your plots can get quite long. And if the plot is just a representation output of the data, then the code is just a way to convert those data into something that looks visually appealing to us and helps us interpret it. But it isn't necessarily important. Sometimes it can be, but if you feel like the code isn't important, such as for some plots, then you can have an output. You said echo equals false. It will run the code. It won't show the code in the output. It will just show the output of the code. All right? So that's echo. Now evaluate or eval. So this is the next one. So eval equals false. And we have the same code here on the left, except we set eval to false, and then we have some code on the right. So if we go back, and now we flip forward, that's echo, and here's eval, we can see that eval has the code output, but it doesn't actually show the result of the code. It doesn't run it. So the easy way to remember this one is it doesn't evaluate the code. So it will show your code, but it won't run it. So in some cases, if you are trying to make an example of some code that you are then going to show to somebody, you can set evaluate to false if you just want to have some, let's say, demo code, but you don't actually want to evaluate it. So for some of the teaching lessons, we've used this in order to show some sort of simplified code, and then other code that we would run would show something else. So you can see there, prevents the code from being run. As a result, no results will be displayed from the code. All right. Include. So include equals false. It runs the code, but prevents both the code and the results from appearing. So this is what happens in the setup function. So what we do is the setup function, I told you that if you have a code chunk name, and you set your code chunk name to be setup, what happens is it will run the code, but it won't include anything of it. Because in your setup, you are setting maybe the libraries for it, you're maybe importing some data, you're doing some things that are just required to get you to the point where you have an environment where you can do some analyses. And so we can manually do that to other code chunks by setting include to equal false. So we'll run the code, but doesn't include either the code or the output from it. Yes, Keith.
For these commands, is it possible to assign only a certain section of the code in the entire code chunk that you have?
So is it possible to set? Are you asking if you could set the same options to more than one code chunk, or?
A certain section of the code chunk. So,
Yeah, no. So this is so the question is, can you set this to a certain section of the code chunk? And this is no. This is a code chunk option. So this would then apply to everything within that code chunk. But the easy thing to do would be just make a new code chunk that has the sort of code chunk options that you want from it. Yeah. You can have multiple code chunk options for a single code chunk, just as long as they don't sort of antagonize each other. You'll see in just a moment. So for example, one that comes to mind is warnings. So oftentimes I'll set warnings to false. So if I don't want warnings to come up, I can say, include equals, or let's say echo equals false, warnings equals false or something. So you can stack some of these together. For some plotting code chunks, you can specify the dimensions of the plots in figure width and figure height. So again, this is starting to set some of the parameters of the code chunk that then will output the plot. So you can, of course, set these parameters within. So this is a base R way of plotting a histogram. You can set some of these parameters within the output itself. But if you generate several plots within a single code chunk, you might want to set a code chunk option so they're all the same size. All right. Now, we've been talking about code chunks, but one of the powers of rmarkdown is that we can run some R code in the plain text section outside of a code chunk. So the way that we do this is we place a little bit of code, not in a code chunk, we're back to our plain text section, but we do this with a single backtick, letter R, a space, some code, and then another backtick. So one example would be today is, and then here we have a function that's sys.date, which you guys could accurately infer that this is going to tell you today's date. But this can go in the plain text section. So it's a way to think about it is it's a little mini code chunk within the plain text section. So this can actually take much more sophisticated functions. So sometimes I want to record the number of, let's say, observations that I have in a data set. So what I can do is I can do backtick R space, and there's a function that's called nRow, and it counts the number of rows, let's say in a data frame. And so the output of nRow is a number. So what I can envision then is the number of samples I have is, then in my code chunk that's going to output a number. And so in this way, I can call some code within this that, again, I can intersperse some of the plain text and some of the R code.
And does that use the language from the normal R language, not the Markdown?
Yes. So the question is, does it use the normal R language, not Markdown? Yeah, Markdown is a different language. We call these R Markdown documents, where it's sort of this hybrid of R and Markdown. But we designate. So it turns out that if you wanted to write some Python in an R Markdown document, you have a code chunk that could be a Python code chunk. It would actually be interesting. I'm not sure if you took a Python, if you did a single backtick. James, you can check this. If you do a single backtick and you write Python space and a Python function and then a backtick, if that's going to be able to do the same thing. I suspect so. James, you can get back to us. Yeah, exactly. So this is a code whose results are inserted into a plain text. So you surround it by this, and only the result will be included in that output. So now's a chance for you guys to play with some R Markdown and get a handle on some of these activities. So if you go to class number 5 and you open up 05 exercise report, you'll notice a long setup chunk. Towards the bottom of it, you'll see some code that stores objects that you'll need to call. So you can go ahead and run these, but what I want you to do is run these code chunks, but what I want you to do is look at the code and see if you can understand what it's doing. When you think you have an understanding, or depending, go ahead and knit the document and see the results. And you can then, the exercise that I want you to do is replace every bold with inline R code, and then remove the chunk so that it's not included in the output, and then finally change the graph chunk so that the output of the plot is shown but not the code, and reknit the document. So I'll leave this up here. We'll have some time. I'm actually not going to time you if I can figure out how to turn off that timer. We'll have plenty of time, so go ahead, take a look at that, and walk through these steps to see if you can figure out how to change the R Markdown document code chunk options to reflect the instructions here, and then also figure out how to replace the R Markdown plain text with objects that you generated to make this inline R code. Okay, so now, you guys, if you try to run this, who has run into an error? Okay, good. That means you guys are ahead of the curve. Okay, so most of you should receive an error. The error says you don't have a package, right? What is the name of the package that it says that you don't have? Viridis. Okay, go ahead and install that package. That should fix that bug and continue on. If you don't remember how to install a package, lean over to your neighbor and see if she or he remembers. If neither of you remember, you can go to Google, Stack Overflow, a TA. So you all should need to install a package in order to run all of that code or to knit that R Markdown document. So you will run into bugs often. Yeah. It's class 5. So you don't, let's see, you don't need to understand exactly, right? Understand as much as you can. Let's see. All right, so you know the first, you're thinking about clotheslines. Those ones, I'm mutating lots of things, right? And then,
That's really good, right?
yeah, these are all verbs you guys know.
Just a lot of that.
Yeah, just a lot of them. Right. Okay. It's beautiful. All right. Now, you just finished number 3. Okay, installing package is good. Yeah.
So when we remove the bold, Matt, with inline code, that would change it from being a bolded word on the PDF to some code that's run. It's just any code. You can specify.
Whatever the thing says.
So this is number, right? So you want to be able to read this now. The blank compartment
Yeah.
has the highest number of unique mitochondrial proteins with blank annotated in this.
So this was bold, kind of two asterisks on your side.
Okay.
You want to replace it.
So go up a little bit. So we
John, that's when you
we store some variables here.
Got it.
Okay. So these are objects. So what I want you to do then is replace what I wrote with a command. So you have an object called top. So go ahead and look at top.
So, but it doesn't cost too much to like.
You can view it, or it should be over in your environment. So you
But
can
no,
just
I
put
see
a little
what you
link
mean.
on the environment. So go to environment, get it looks right. Scroll down a little bit.
Okay, so that's where you
Is it
go
all?
inside what's going to print as text. You can add pieces of code instead of text.
Have you run all this?
Do that.
So you knitted it, but make sure you run it up. You don't have the option, so go ahead and run all. Run that. And then take a look at the top. And what I want you to do is figure out how to call this market in top.
Turns out,
That arc,
maybe
that
like
line arc right there.
What step is that?
that filters for your favorite gene.
Knit it up, it's a big code.
And we want it to print the compartment that's in, right? So that's locations.
Right. So the question there is,
And if you go over,
why was the setup chunk
that's the
created?
end. Okay? So now we have it in. So then right next to it, so you can see it. So now you see, it has the compartment doesn't have that piece of code, but it's now it's
That's what you put into the
reference.
Oh, no, yeah, that's fine.
So
That's what it should
in
be.
the,
You just ask me
our
like
Markdown
that.
file, it's here, it has this text, and I put in this little chunk of code here. Yes. Yeah, so the black space on your left has the space. Inside the gray area is yeah, that's the code. Yes. Mm-hmm. Yes.
So that's from, so how,
is
So I
very
wonder,
deep. And then,
place the word
The hot.
you can look at that.
so which summary?
Right now it says.
In the knitted file, so in the knitted file, this is the same
You wanna
chunk where
replace
you
the highest
link
and
all
bottom.
the parts. But
What
you
if
see
it's
part
just
right here, that's that piece of code that asks us to reference the location, right? So now what he wants you to do is replace the number and it's the favorite gene name.
It's actually
And
changed, so it's not such a.
So, it helps us you make this object and then look at what your variables are, what our names are, and then you just add each.
What's the command?
Yeah, and then you could delete those, because you don't
Yeah,
want
so
it
placenta
to
is
say
the most.
perfect, like the heart has a minus.
So that's,
right.
so,
Right.
Well, as long as it's in the code.
Yeah, exactly, yeah.
okay, so that's fine. So how do you write then?
So this has like symbol, location.
What do they call it back?
Yes.
Exactly, what's the code? Exactly. So then,
This one?
So actually,
So now you have this,
This
and this data set.
it's gonna be, yeah, this is our answer, right?
So
How
we
do we
made
call
This is
this answer?
Oh, okay.
Is up top.
This might have had a class.
yes,
What you do
he's made objects.
is you take your data gene.
And then,
So how would you write,
Yours is
what's
right.
called, one backwards in that data frame?
So if you look at.
so then, for this, my favorite gene is, then you would say, go fetid,
Yeah, dollars.
in this case,
Ooh.
alright, you just have to look at what the variables are called, yeah. He filled in this data set where the symbol is the name of his favorite gene, so you can replace that with whatever you want. And then you just, so that should be
So just the
only data regarding that.
Location, I don't know, I know that's compartmented.
Okay,
Oh, yeah, you deleted one of your.
so he, so he wants you to make.
Oh, that's all I'm saying. Yeah, so right, so we don't get the hot.
This stuff.
Then it's going around through.
So it's tricky to have to go through all of this code.
So the first thing
yeah, we
is
should.
Number would be.
So you did by number.
So,
It'll be.
The subchunk was implemented in third form, which is the subchunk. So now we
This is,
I guess, he figures it out. Just
so you wanna write in like.
And the way to check it, like this is an object, I mean, this is an object.
And
The
just
object then has a vector that you call this. That's just say placenta, right? So if you knit that, the placenta has to be with this number. So now what do you want to get this to be a number.
Right? So
Or
now.
top, then you have to run this thing first, which puts it here. Yeah, it's there. Well, I mean, it generates it in your environment. Yeah, and that's the work that I did for you guys. So yeah. Let's try to figure that out. All right. You guys getting it over here? Yeah. Okay. Good.
It
Louis?
looks a little tight. So now you want the number and, so when we say we made another opportunity, that but
Yes.
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 I have no idea what the name of that gene, the component.
Okay, well, so we just went over the way to put inline R code into text. Okay, that's a backtick, the letter R, space, some code. Okay.
R space.
Yes. Now, if you go to this top here, just randoms, that's what you're saying. So, did you write that one? That's not quite exactly what you're saying. So which tissue has the highest number of Exactly. So how do you just from this top object? Actually,
Oh, I see. You're keeping it.
top location. Oh, so if you click on that, something about location,
remember how to call a specific element within an object? Yeah. So this doesn't have because top is an object. Well, it does. But
it's got 3 pairs.
But it doesn't have all the other information. So if you scroll up, these are top doesn't have what name.
That's not very good. This is top.
That's the way.
I want hand.
But you want
Yeah. Because
Oh,
this is
one,
how I'm
one.
knitting it. So, this is
So-
what the output would look like. You
So
can
you
run
want-
it
you
without
want
showing
fake.
it, right?
So that's all. And if you fade, so in this case, like if you left it at 10H2, you can choose. Let's say 10H2. You could fade. Yeah. This has all the information in H2. So then you would do exactly what you're doing, except replace down things.
Sure. Yeah. Go ahead and put that note in the base.
So these sort of work with,
And H top. Yep. Out of them, errors it. Go on the line session provenance.
we're supposed to do other things.
I'm just going to walk through a couple of things with you guys.
So another cell.
All right.
There's a really good set.
If you go to console, you can see something. Oh, it's really updated. This is really annoying. Now it works.
Okay.
Oh, when it does.
Okay.
Top location used to work.
On top of station. Oh, no, but that's not top. Is the location of the top. There'll only be one answer. But oh yeah,
You said that.
it should. Unless you do top. Well, you can't. That's the thing. When it's here.
All right, let's try to walk through this together a little bit. So this was the idea. All right, so step 1 is to knit the document. So remember, if we want to knit a document, we're going to tap on this button here. This is knit. This is what runs it fresh, okay? And we can see what our report looks like if we run it fresh. Let's see. Okay. So we get something like this. So this is a nice looking report. So we've got like a section here. Students start here. We sort of look at our data. We have a data frame called mitocarda class 5, and then we group by location, and then we count this true false logical whether or not our tissue is in or our protein is in this tissue or not, and then we sort it. Okay, so we end up with this list. So this is our list of mitocarda class 5, group by location, counting the number of proteins that are in each location. All right, now we store that object so that we can call it below. We could run this command every single time, but we might as well store this because we're going to then want to use this for our report. So I take all of this, I ungroup, and then we have this function that's called slice, and this is going to take the very top line. Okay, so we're slicing, and we're slicing one row, so we get what we call top. And this is just going to be row 1 of this data frame, which is here. And then here, this is for a little bit lower, a little bit later. We can do the same. We can do a similar operation. We take this, but instead of counting everything, what we can do is we can filter. The symbol is on a gene, mitochondrial gene. So I have a favorite mitochondrial gene. It's malate-dehydrogenase. It's my favorite because we share the same initials. So hopefully you all have a favorite gene. And then what we can do is we can find all of the tissues that MDH2 is in by arranging based on descending intensity of our signal. And then again, we slice. So this is some favorite gene information.
Are you the second?
Can I ask, Matt?
Yeah.
So why is that, in the first one you did the ungroup,
Mhm.
and then the second one was slice?
So what happens is if you group by location and then you count, this is going to be helpful, but all of this data is still grouped. So if I want to do an operation, I need to ungroup to then slice this. So ungroup oftentimes pairs with group if you want to do something to it after. If I just wanted to count, you can actually see here, if I just looking at it, I just can count, that's fine. But if I want to do something to this, I need to ungroup it. Okay? And slice is just the way that I can slice the first row. All right, so I've got some code, some code output, some more code. And then here, the whole idea, it would have been more clear for me to say that this is tissue. But the whole idea is that I want to then clean this up, and rather than saying, like manually writing these things, what I can do is I can change the code to reflect this. And then what I do here is I can then have a pretty output. Okay, so this is what it looks like. But if I go back to the instructions, then the instructions are to replace every bold with inline R code, to remove the student's chunks, so it's not included in the output, and then change the graph chunk so that only the output is shown. Okay, so if I wanted to do those things, I would do something like this. All right, now, if you guys want to check your work, I did give you the answer right here. So if you go to the 05 exercise report answer .markdown document, whoa, I do that every time. So I just got rid of the whole thing. So all right. Go like this. All right, now if I wanted to change, so this, okay, it should look something like this. I've got a backtick R top location, has the highest number of mitochondrial proteins with top N. I showed some of you, what you could do is if you just highlight this piece here, and then you say run selected line, let me just run all of this. Then what you can do is you can get a quick answer if that's going to give you the output. Because remember, when you do this backtick R, this is just going to report, just give you the single output. So in this case, it says placenta. And I can do the same thing here. My favorite gene is, so hopefully you had a moment to go and change to your favorite, the official gene name of your favorite mitochondrial gene. You can put that in here. And then what you do is you create a different object. This object is fav, for favorite. And so I take fav symbol, which encodes a mitochondrial protein that's most abundant in this location and is this many amino acids long. All right, now if I wanted to run this, but not include the, what did I say here? I said I want to remove the student's chunk so it's not included in the output. All right, what would I put here? I could put include. So include runs it, right, like this. And then here, if I want to change this one so that only the report output and plot are shown on the knitr report, what do I do for this one? Yes, exactly. Okay, now, if I knit the whole thing again, then we'll see how this report looks. So now it's much, much cleaner, right? I have a title, a header, I have a favorite gene, and then I have a piece of text that looks like I just typed it out, but we know that this, and this, and this, and this, and this are all called directly from the from the data. Now, the nice thing about that is if my favorite gene changes, and now I'm like way into citrate synthase, I can knit, and I can say, still, this is going to be the same, because that doesn't change. This doesn't change unless my data set changes. But now my favorite gene is citrate synthase, because of mitochondrial protein that's most abundant in the heart, and is this many amino acids long. All right? So this is now the power of it, where we have these reports that we can call directly on the data. And let's say we do something to the data, that we filter it, or we count it differently, or something. We can capture that those changes in this report by simply coding some of these variables into it. All right? Does that make sense? So this is where some of the data provenance and reproducibility really comes into play, where if we're trying to, write a report that counts the number of, again, the number of observations, we can hard code that in to make sure that we didn't mistype it, and we didn't, maybe in some future parallel universe, we'll just write all of our papers in something like this, where we can make sure that here's the data, here's the code, here are the figures, and maybe eventually here's the paper. And the paper then calls the data in these ways. Okay. Any questions about that? All right. Moving on. YAML, yet another markup language. So YAML headers are the next section that we're going to go over. So remember, this is that small section in between the dash, dash, dash at the top. Okay, so the way to think about these YAML headers is this is a section that has what we call key value pairs. So a key value pair means every key that you put there has to have a value. And so as a simple test case, we can put information into the YAML header, like title. We have something that's untitled in this case, an author, a date. This is a hard-coded date. But most importantly, when we knit, I told you, knit first converts your document from a rmarkdown to Markdown, and then it goes from Markdown into all of these alternative outputs, useful outputs. So this is where we define the output. If you take a moment and you go back to the exercise underscore report that you just did, let's take a look at that header. So we knitted it, and the knitted document had a title. In this case, it had a subtitle, and the output is HTML. So when I click knit, it's going to make an HTML file that this opens in, and still in this case it's Safari. But this is a HTML file that then is going to have a title, it's going to have a subtitle, and then it's going to have the output of the document. Okay? So we can put some of this information into the YAML header, the most important of which is the output style that you want. Now, again, on the cheat sheet, on the rmarkdown cheat sheet, you'll find the output field that sets the value of this key value pair for what you want to make. So HTML, PDF, Word, open document, text, all the way down. So these are some of the most common. I know that there's active development for different types of rmarkdown outputs, but this should get you the most most of the way there. So that was probably the most important thing to put in your YAML header. The next is parameters. So parameters are a way to take a report and to change several different aspects of this report at once. So here's a small exercise. So go into the 05 folder. This one will be a little less painful than the last one, I promise. And then open up params underscore exercise. And then you can click knit if you just want to knit the document. But one of the things I want you to do is click the little drop-down menu next to that knit button. You should see a little black triangle. If you click on that, one of the options should be knit with parameters. And I want you to knit with parameters. You can keep the parameter that's in there just like that for now, and then knit the document. But then go back and do the same and enter a different parameter. So it should look something like this. So if we look at the YAML header, you can see now I've highlighted this in blue. I have a title. I have a subtitle. I have an output, so this is going to make another HTML. And now I have a parameter, a list of parameters. In this case, I only have one. And this is a key value pair of, again, gene and my favorite gene. So if I click here and I go down and I select knit with parameters, then what will happen is I'll get a pop-up. And this is an opportunity for me to change the parameters. To start, we'll just leave it like it is. And I'll say knit. And I'll get an error. Okay, and the error is related to this very last line. Don't worry about that for now. You can just comment that out. Error goes away. All right, so I can knit this, and I get a pop-up blocker. But then what I have is I have a class 5 report exercise. My favorite gene is MDH2, and it codes mitochondrial protein. So you should see this. This looks familiar. This is from the last, some of the text is from the last exercise. But we can see it's most abundant in the heart. It's 388 amino acids long. But then here I actually add one more calculation. The average length of proteins in the heart is 370 amino acids, which makes MDH2 shorter than average. Check our math. 338 is shorter than 370. Okay, good. Now, let's come back, and we'll go to knit with parameters. And I'll take my other example. In this case, I can change my parameter right here. My second favorite is citrate synthase. Do you know why? It's the first one I thought of. Okay, so we can look and see here. Now what happens is the report changes. The report changes, so now it's going to list citrate synthase, but it's got some interesting information about it. Citrate synthase is most abundant in the heart. It's 466 amino acids. The average length here is 370, and it makes citrate synthase longer than average. All right. Let's start to get wild. Anybody have a short protein? What's a really short one? It's a good one. Any favorite mitochondrial proteins? Darren, cytochrome C?
I'm trying to think of short ones.
How long is cytochrome C? Is that the gene name? Nope. That's not the gene name. CYC1 maybe? Okay. My favorite gene is cytochrome C because of mitochondrial protein. This is most abundant in the brainstem. It's 325 amino acids long. The average length of proteins in the brainstem is 390, which makes cytochrome C shorter than average. This is like magic, right? This is like an app. I should put it on the App Store and get rich. No, so go ahead and do a couple of them, and then we can look at the code together. So this is how parameters work. So the code here is just code. It's mitochondria class 5, the same one that I made before. I've got mitochondria. I filter, so I want only things in mitochondria, and then I mutate to this basically this really long if else true false to basically say, is this in this tissue? If yes, true. If false, no. So then what I do is I summarize these and I add them up, and then I make something that's long so I can plot it. I group by location, I count, and then I make another data frame here. This is called intensity. So this is not going to be super important, but essentially what I'm going to try to do is I end up getting rid of intensity. That was just a sort of something that would help me along the way. But I end up with mitochondria class 5. And this is going to be then my symbol, my location, whether or not my gene is there, intensity, protein length, and all the way down to all of my genes. So then what I can do is students start here, okay? So this is already include equals false, just like from before. But now what I can do is, this should look a little bit familiar. My favorite gene is this, which encodes a mitochondrial protein that is most abundant in this location. If I come up and look at location, class 5, so here's top. So top is the same as it was before. But then what I do is I basically make two other little data frames. One is called average length. So then I have a data frame that I can compare mine to. Favorite is the same, but then I have a little if else for if it's longer or shorter. So you can look at that code if you want. But that's the idea about parameters. So the idea of a parameter is that you can set a piece of code in the YAML header. In this case, the parameter is gene. I have a default for gene is MDH2, but I can change that. And if I change that, then it can change to something else that is in the data set that can then change the rest of the report. Keith?
Is it possible to write a code where you're essentially telling R to knit a series of different documents?
Is it possible to tell R to knit a series of documents? Yes. Yeah. And it's also possible, this is outside of what we'll talk about today, but there's something that are called child code chunks. And so you can have a sort of parent and child code chunks, but essentially you can have a code chunk that runs in a document that is written in another document. So you can have a code chunk somewhere else that you can then write. So you can think about, so now we can get sort of wild and crazy with knitting, where you can knit different pieces of different documents or several documents together to generate an output. Absolutely. All right. Did you guys get a chance to type in a couple of different names? See how the output changes? And it's not just like, ooh, isn't this a clever trick? The idea then is to go and take a look at some of the code. And we'll be around today, this weekend, whenever, if you want to really get into the code and how we did it and what we changed and so on. But what you should be able to recognize is this inline R code to call different elements that then get updated based on what you feed it. Okay, so that's parameters. So you have this list of values that you call in the code chunk. So in some cases, you can have multiple parameters. You always have to have a default, but of course, if you click knit, it will knit with the default parameters. But if you say knit with parameters, you can then specify the parameters that you want. So you have a colon, you have a new line indented with 2 spaces, because again, this is going to be the way to have a Markdown change it. So here's a very simple example. Call parameter values is elements of the parameter list. So the way that you call this is the same as calling a vector of a data frame or an element of an object, where you have params, money sign, number, is going to then call 42. So the value of parameter is r params num 42. Okay.
In the exercise, I noticed in the last slide you showed
Mm-hmm.
the parameters that had data file, or like
File name?
file name.
Yeah.
I don't see that in yours.
No, I didn't put file name in mine.
Okay.
Yeah.
Why is that?
Because I didn't have a file name to call. You can call parameters anything. I mean, parameters can be just a YAML header looks for title, looks for output, looks for params. But within params, you can have any key value pair that you want. So I have gene, right? And gene is a key, and the value is MDH2. Here, file name is data.csv. So if you want to run a report based on, let's say, different files, imagine you had 3 proteomics files and you wanted 3 reports for each of those, you could have the parameter of file name where you just specify the file, and then the knitr just rips through all of the code, generates the file, and gives you the output. So you can have whatever you want here, and you could have a date, you could have all of these things. So now, if you reinspect the params exercise, how many times do you see the parameter was called? So go back and look for parameter. You can do a Command F or Control F to find params, but how many times do you see params called in here? Okay, we have a vote for 1. We have a vote for 2.
The subtitle counts.
Subtitle counts. Yeah, it's 2. So there's 2 different places that I called parameters, and you can see where I called it. So one is I wanted to change my subtitle to my favorite gene. So if I change my favorite gene, then I can have some element of the report changes to let me know what the parameter was. So that's kind of important. Like if you're going to be changing parameters, especially in the fly, you want to have something that captures that, especially for this provenance and reproducibility. Be a little bit silly to say, oh, here's my report I generated from the data. And then somebody asks, well, which data set did you use? It's like, oh, I I should have written that down, right? So it's a good habit to call the parameter within the knitted report, that output. And then you can see I call it here. So I filter the class 5 data set where symbol equals params money sign gene. So this is exactly how you do it. So, and we could do this like, just step by step. So if I go here and I run it, I see something like this, I get everything. But if I run this step by step, now I have just the MDH2 locations. Then I go here and I sort. Now my MDH2 is located based on intensity, and then I slice, and now I have my top value. And so it's this favorite top value is then I call MDH2 is high in the heart. Its protein length is 338. So that's how that works. Okay. Now, we have a little bit of time. You guys can try some of the homework. We will. There's one other thing I want to go over before I let you go. But there is an exercise that you can do, 05_homework, where the main point of the homework this time is to look at some of the data sets that we will be potentially using for the final project. So what I want to do in just like the last couple of minutes here is to go over this idea of the final project. So before we go over this, any questions about knitting? It should be easy. It's a single button. We can have some parameters, right? So where we can incorporate some things. That's like, the next level. But essentially, this is the way that we generate a report for our colleagues to see, perhaps our PIs to see, right? So this is the output of some series of analyses that you then can save, share, record.
Are there any forms of knitting where the file type is actually reversible? You can go back to see what the code is, or is it's just once it's knitted, that report is just static?
So the question is, can you go back? So no, you can't. As far as I know of no like Word document to Markdown converters. There might be within like Word as to file save as Markdown document, but there's no way then to go from that Markdown document back to the code that theoretically generated it. But knitting doesn't destroy the code at all. So you should like that's the gold master.
And the code, you'd send it both.
Yeah, certainly. Or you say, the code's on GitHub, here's the report. Yeah. Any other questions? Okay, now, so today's Friday. Tuesday at 2 o'clock in this room, we will have a series of presentations for you guys to perform, to share the output of a final project. So I want you to go to 06 final within the project repository and open up Hershey RMD. It looks like we have 3 packages that we need to install. Our Markdown is clever like that, where it can tell us what we need. So I'm just going to install these for a second. So the idea is to synthesize everything you've learned over the last week to put together a small analysis that then you can stand up in front of us for 2, maybe 3 minutes to share what you found. And so this will be a walkthrough of what you did. So you'll have your code, and then you'll have essentially your knitted report. You can keep your code in your report, but you will walk through the analysis, what you found, and then maybe what you would do to follow it up. So one example of such a presentation would be, hello everybody, my name is Matt. I'm in the Hershey lab, And today I'm going to be telling you about my Tidybiology final project. I first loaded the chromosome summary data, which was originally scraped from a Wikipedia entry about the human chromosome. I took a glimpse into the data and in the data frame, and I found that it has 14 variables and 24 observations. The 24 observations are 22 number chromosomes plus the X and Y chromosome. And then I had some interesting information about each of these. I did some exploratory data analysis. I explored the relationship between the protein coding genes and the number of base pairs. Perhaps not surprisingly, generally longer chromosomes have more protein coding genes. But then I got curious about variation. So I started looking at protein variation. I generated a new column looking at the percent variation in each chromosome. And then I chose to investigate this relationship and made an exploratory graph of this. And this is what it looks like. So it's interesting because I found that the X and Y chromosome clearly have lower total number of variation compared to the other chromosomes. You can see that if this is our trend line of all of these, X and Y are much lower. But I was trying to figure out the best way to visualize this. So then what I decided on, as I chose a lollipop plot, to visualize the difference between the chromosomes variation compared to the mean variation. And this was my output. So I end up with, shrink it, there we go. Maybe one more. So I end up with something like this, where the sex chromosomes have lower genomic variation than other chromosomes. And this is a little subtitle here, assessing genomic variation in each human chromosome. So this right here is the mean. And you can see that there are human chromosomes that have different amounts of variation. And so the average is 4.9, and then I have my X variation, and then my Y variation is the lowest. So I conclude that the amount of genomic variation is the lowest on the X and Y chromosomes compared to the remaining human chromosomes. This observation implies that the fidelity of the DNA sequences is more stringent, and unique mechanisms are in place to ensure low variation on the sex chromosomes. To prioritize follow-up studies, I maybe would look at chromosome states. These are known to influence genomic variation. Therefore, I could look at the chromosome state at these genomic loci, histone modifications, DNA methylation, etc. And then maybe some acknowledgments. I would say I'd like to acknowledge Cedric Scher for plot inspiration. He has a nice blog post that walked me through how to make a lollipop plot. And then these guys in the RStudio team for making the tidy packages, and you all for reaching the end of the class. Right, so go on. No, so this is the idea, right? This is a short 2 to 3 minute presentation where I took this data set, I imported it, I explored it, I looked at this, that was completely irrelevant. I looked at this, I got curious about that, and I thought about how to visualize it, and this is what I finally showed. So that's the idea. So I was thinking that we would do this Tuesday. 2 to 4 o'clock is what we'll block off. There's a seminar in this room at 4, so we should be done by that seminar, but we can hang out. I'll bring some beverages if you guys would like to drink them with me. And we'll essentially celebrate the end of the class. And we can ask questions, and we can, it's just going to be a really relaxed culmination and celebration of you guys getting through this. So that's the idea. So what does this look like? Well, it would be, I made a template for you. So we have a 06 final project. There's a template in there if you'd like to use that. And then essentially there's one RMD document, and then I presented from that knitted report. And like you guys saw, the whole goal is just to very quickly review the data, the output, using the output file, some of the salient observations, and then hopefully some strategies to test the hypothesis. Then a couple of final concluding thoughts of this course and this activity. So data science, to me, enables data-driven information gathering and hypothesis generation. So this is essentially two activities that are intimately sort of related and linked, where we have our own scientific research enterprises where we are generating data and we need to extract meaning from them to push a project forward. But also there's this other activity where we're trying to gather data before we start a project to think about this, the validity of a hypothesis and to think about how to approach some of our experiments in the lab. There's maybe a third, which Keith and I are trying to explore, of using some of these tools to systematically review literature and to ask questions about and assess the state of knowledge related to a topic based on using some of these tools. I think that having these tools at our disposal enables the ability to ask new types of questions. And it's interesting because this is a activity that is oftentimes process-centric, not necessarily gene-centric. And what I mean by that, I think will be intuitive to several of you. So if you have a large-scale data set, very rarely can you go to that data set and say, I want to ask a very targeted question about my gene, because you end up with a gene list of presumably genes that are completely unrelated or presumably unrelated to the question that you asked. And so we're able now to take a set of skills and apply them to various types of projects to understand biological processes, maybe that tells us something about genes, but certainly about processes. And the thing that I think is most surprising is this concept that making things computable makes them actionable at zero marginal cost. And so what I mean by that is when we do some of these analyses, especially before we dive into a project, it means that it doesn't cost really anything, maybe some of our time, but it doesn't cost anything to dive into data sets to strengthen a hypothesis. Or let's say we have a data set from an omics lab that we then can analyze and dive into, but we need to go even further than just, here's my gene list. We can then go further and say, well, are there other data sets that will help me validate or prioritize some of these follow-up studies? So, and then the main key of the lecture today is really that some of these workflows will save time and importantly achieve this reproducibility initiative and responsibility that I think we all have. So, a couple of final resources. So the first is, before I forget, on Monday here at the same time, Akshay has graciously agreed to be available to help you all with sort of an open office hours with some of your code. So we will have Tuesday at 2 o'clock in this room for a final presentation. But Monday at the regular time, 1:30, Akshay will be here. He just asked that you bring him food to feed him, but he will be here to help you with any of your questions if you can't get through something or you keep having a bug or some code or something. Also, the Slack channel for Tidybiology, the three of us will look at it this weekend to make sure if you have a bug that you can't solve or trying to figure out how to do something, or what is it exactly that you said, how do we do this, like we can certainly help, so just post a question there. Resources, so we have cheat sheets. We've talked about these a lot, but these will be your friend. I can't really do any programming without consistently having a cheat sheet or four open on my computer. Stack Overflow, if you Google removing legend title ggplot, inevitably you will find the Stack Overflow resource, probably the same answer and question that I keep clicking on when I need to figure out how to do that. So remember, Stack Overflow is your friend. R for Data Science, a fantastic book by Garrett and Hadley, really sort of formally and systematically introducing several of these concepts. We took several vignettes from them, but this is a good resource. Yeah, James, question?
You said there was a free PDF of this somewhere?
Yeah.
Would you?
There.
So the link is posted?
Yeah. Yeah, it's not a PDF. It's all written in this actually R Markdown package called Bookdown, but the entire book is available online.
Cool.
Yeah. That's one of the wonderful things about this community is that everything is open, everything is online, everything is free, everything is this. Look at this class. Like, this class is me trying to help you because there were people that helped me, and then one or several of you will then go in and teach somebody else something and teach somebody else, and so on. Okay, we mentioned this a couple of times. There's this activity called Tidy Tuesday. If you really like this idea of data visualization, once a week there's a new data set that is released that is a data visualization challenge, essentially. Sometimes it is an attempt to try to recapitulate a graphic that was made by, let's say, the BBC or somebody else. In other cases, here's a data set, go explore it and see what you can find. The only warning I have about this is you can find yourself down like a rabbit hole really, really quickly. So I did several of these at the beginning. I quite liked them just because it was a challenge to try to come up with a visualization. But the most interesting thing to me was to see how other people did their visualizations. So when it was just an attempt to recreate something, okay, that's fine. But if you have a data set and then somebody visualized their data set in this way, it's like, oh, I didn't even think about that, or I didn't even know that we could do that, or that's a really good way. It's like what I was talking about with this genomic variation. Like I noticed that the X and Y were lower, and I wanted to capture that somehow, but I wasn't quite sure how. And so I chose one way, but if there were other people that chose other ways to visualize, the same information, I think that that's interesting. And then lastly, my acknowledgement slide. So let's give a round of applause for Ali and Akshay, our fantastic TAs that certainly generated the lecture material and I think are an asset to this class. Inspiration, ideas, packages, and code. So the R for Data Science team, Mine, Chester, Garrett, the Tidyverse community, R Studio. Really, R is built upon the tremendous open source infrastructure of R, and so I've used several of their concepts and packages and ideas to try to teach you guys. So I need to acknowledge them for that. So. With that, it's not quite to the end of class yet. I'm happy to stay around if you guys have questions. But I hope to see you Tuesday, 2 o'clock, to give a short sort of celebratory culmination of our time together. The last thing that I'll just mention is my sort of long-term plan, and this is just an email for you guys to watch for, is part of the reason to try to do this boot camp now in December is because in January, Ali and Akshay and I will start a Tidybiology meetup or some concept like that, where once a month here in the building, we'll plan for a sort of ongoing continuing education, maybe some practical code-alongs, some vignettes of maybe what people are doing. We're still working out the format, but the idea now is that you have some tools. I hope that you'll continue to use those tools through this weekend, through Tuesday, but then of course the idea is to keep the momentum going and to be part of this, build a little culture and community around some of these activities. So watch for information about that. Thank you all.